As we previously discussed, secondary storage is storage outside of memory. This can be PDA storage, it can be flash drive storage, it could be hard disk drive storage, it could be network disk drive storage, and nowadays it can even be cloud storage, which we've discussed. So secondary storage is storage that is outside the memory of the computer. So usually that's something that we see and hear about on your computer's hard drive. And hard drives are broken down by file systems. So different types of operating systems use different types of operating systems, but there is some compatibility there. For the next slide here, I'm going to continue on to this site here, How to Geek. So this is the URL that you can reference and read for yourself. This is a really good website for general information and troubleshooting. I find myself coming to How to Geek quite a bit. So let's talk about the FAT32 file system first. So this is a Windows file system. It's an older file system. There was a FAT16 file system even before that. So it was used up until Windows XP. A lot of smaller devices like your flash drives and your storage drives will still use that nowadays. I will go ahead and insert a flash drive in here right now. This is one of them that Albertus likes to give you when you register for classes. It's a smaller drive, but I'll put it in right now and we'll show you how we see that here in just a second. Next we have the NTFS drive. So when you put your Windows XP, your Windows 7, your Windows 8, 8.1, your Windows servers, all modern Windows versions use NTFS for the file system. External drives can be formatted either way, but NTFS is more reliable. It's more stable than the older FAT32 file systems, and it's used with larger disk drives now. So the HFS file system is what's used by Macs. It's pretty much used to format all their computers and stuff like that. Macs, however, are also able to read FAT32 file systems. Although they can only read the NTFS by default, so a lot of third-party software and vendor support is needed with the HFS and the Mac file systems. They're not too compatible, but pretty much everything seems to be compatible with FAT32 for external drives. The ext1, ext2, ext3, and ext4 are Linux-based file systems. Nowadays, the ext4 is the standard. I believe it stands for Extended File System, and it doesn't like to read well with Windows and what have you. However, Linux will read any file system pretty much that's a Windows-based file system. For that reason, a lot of times when you format an external device on a Linux machine, it's still recommended that you use FAT32. So this BTRFS file system, we're not going to be working with this. It's still mostly in development right now. So here they're calling swap a file system, but I don't even really know why this is on here. This is really, a swap file in Linux is the same thing as a page file in Windows, and it's really just a dedicated partition regardless of whether you're using Linux or whether you're using Windows. So I don't even know why this is here. I don't actually want to go into this right now. I'll do that later on. But going through it real quick, FAT32 is an older Windows file system. NTFS is a modern Windows file system. HFS Plus is the Mac file system. ext4 is the current Linux file system that we use, and this is a development Linux file system. I've never actually seen one of these. So we're going to go on in just a second to the Linux directory structure, and I'll lecture on that in just a minute. Thank you very much. So why don't we take a look at the Windows Explorer before we go ahead and look at the Linux folders. So right here, when you click on this PC, it will give you a good overview of what your Windows folders and your devices look like. So that being said, as you can see right now, it's showing that I only have a C drive and a D drive, which the D drive is a DVD drive. I know for sure I don't have a DVD in this machine, but if I take that jump drive, that Albertus flash drive that I was talking about, and I put that into my computer, all of a sudden I have an E drive, which unfortunately there's absolutely nothing at all on this disk, but it has its own root right there. As you can see, that's E with the backslash, the Windows backslash. And if I were to go back to look at my PC view, I could also look at my C drive here, and it has its files on it here. Okay, so going back to the PC view for 1 second, I did want to demonstrate that if I go into properties, it's a FAT32 file system. So like we were discussing previously, the FAT32 file system is tied to smaller flash drives and USB jump drives and what have you. The local C drive is actually internal inside my computer. It's a much larger drive. It's almost 1 terabyte. So if I look at the properties for it, it's an NTFS drive, which most C drives on your computer will be NTFS if they're newer machines. So I wanted to bring that up. Now we'll go through and we'll look here. So this is the root of the C drive right here. Okay, so it's designated just like that. So C colon with the backslash, that shows the root of C. So program files is an important directory. It shows all of your files that and all of your programs that you run that are 64-bit programs. So all of these programs here are 64-bit programs that I'm running on this machine. The 32-bit programs are under the program files x86 directory. Okay, so these programs in here are all going to be 32-bit programs that are running. Program data, these just break up into folders. It stores a lot of system-wide program data for different things that get opened and different programs that get used. The user directory, we'll look here at user public because it's a much more broken down view. And because it's public, it's going to say public in front of these, but this is actually going to be just the desktop directory, the document directory, the download, the music, the pictures, and the video directories. These are pretty much set up by default with most Windows systems, so if I were to go ahead and look at my own folder here, I have a few other items in there, but again I have desktop, downloads, documents, videos, and so on and so on. So going back, then you have your Windows directory, and this is where your actual operating system exists. This is where all the libraries that support it and the kernel itself are located. So good directories to look at here are the fonts directory that stores all the different fonts that your computer will use. You can go down, you've got the system, where somewhere you have the system and the system32 directories. Those store all your drivers, your device drivers, and your program drivers. And if you go into system32 under drivers, you'll have an etc directory which stores the host file and your services file, and we're going to go into that in Windows, and we're going to go into that in our Linux, Unix environments. So those are just an example of some of the file systems that are important in Windows. Thank you very much. Moving on, I'm going to connect to the Raspberry Pi. So take a networking class. This is not going to be how you will connect to my Raspberry Pi to do your work, but this is how I'm going to be connecting. So I will provide you with the proper URL information when the time comes and the different how you'll connect to this. Right now I'm just setting it up here, so something I will point out is you're just going to type your IP address or your host name here, whatever I give you, and you can type a save session name and save it here. You're going to want to make sure that SSH is selected. I am thinking about configuring port 22 not to be the SSH port for the purpose of this class, because every hacker in the world knows to look at that port, and having SSH open to the outside world is a little bit risky. There's nothing that important on my Raspberry Pi, so I'm not going to get too bent out of shape about that. And when we select the keyboard from the terminal here, we want to make sure that Control H is selected, because that will allow backspacing. and otherwise it will be much more annoying. So now I click here on the Raspberry Pi and it should connect up for me. Unless it's not on. Well, it is on, but it's not connecting for me. That's not what I was expecting. Maybe it's 1.68. Aha, that was the problem. I had the wrong IP address in there. So this will be your login prompt. For now, I'm going to log in as root. And the Raspberry Pi is waking up still. We know it's connected because it does give us the root login. Now if I log in here, I am not in the root directory. I'm in the home directory for root, which is /root. Okay, so now I'm going to do an ls-l here. Oops, excuse me, I wanted to go to the root. I'm going to do an ls-l PRA. That'll give me everything in date order. So these are all the directories in the root file system on this Raspberry Pi. Before I go into too much detail on this here, I'm actually going to click on this Linux directory structure here. And I'm going to go through this on the next set of slides. So this will make much more sense in just a minute. So now if you all remember from our Windows discussion we had a few minutes ago, they can have a root of the D drive, the root of the E drive, the root of the C drive, the root of any network drive. So there can be many different roots and many different types of file systems that all connect in to a Windows environment. And there can be, and there's separate drives, and you can actually see the drives very clearly and very simply on a Windows computers because the drives are usually designated by a drive letter, and it's usually really obvious. It doesn't work that way in Linux. Every folder you have in Linux is based off the root, and the root is a simple slash that looks like this right here. So on a Linux computer, everything is at the base level off of the root. So you'll have separate drives that get mounted up, but they get mounted up, and I will go through that in just a second here. So under the root directory you have the bin directory. That's where the user binaries are contained. These binaries are programs that can run and that are useful to the user. Under sbin is where the system binaries are going to be located, which are the system programs and the system commands. These will be used when you're doing administration on the server itself. All of the configurations for all of the different applications that are configured on a Linux machine are primarily stored under the etc directory, and that's pronounced etc. So this will have all your services that are running. It'll have every different type of application that you might have installed. So for example, your web server, if you're running your Linux machine as a web server, your web server configurations will be under this folder. So all your configurations are contained under etc. Then there's the process information folder and directory, directory. So there's not going to be any time that you're really ever going to use this. It stores your various processes as they're running. Okay? Then there's the var files. That's where your variable information is contained. So for you going back to the website example, your configuration for your website will be contained here, but your actual website files will be located under var. So on a Linux machine, for the most part, var www is going to be your web server. You'll also have your login files, which are stored under var for the most part. So a lot of work gets done under var. It's an important folder. There's also the TMP folder. This is the temporary files folder. This is where temp files get created and stored. This can get blown out really easily, and you should never put anything under temp that you don't expect to lose at some point. So user programs. So when a user writes a program and the user does some development, has a CGI script that they're using with their website or what have you, it's best practice to put it under the user folder. Now the home directories, with the exception of the root home directory, they're stored under here. in this class you're all going to have logins to my Raspberry Pi to do your work in. Your logins will be under the home directory here, and you'll see that very shortly. So the Bootstrap and the bootloader programs are often kept under the boot directory. The system libraries and the system source code in Linux and what have you, you might have your C program libraries, you might have some Java libraries, but your library and your system information stuff is going to be stored under the lib folder, which stands for libraries. Any kind of an optional add-on is going to be under OPT. I see more OPT folders and files being used on Unix systems than I do with Linux. That's just an observation. The mount directory. So if you were going to mount a separate drive on your computer, like you wanted to mount up a CD so you can read something off of a CD, or you wanted to mount up a DVD, or you wanted to mount up a flash drive or something, usually they get mounted under here. So like I said, you won't see a separate drive letter or anything like that. You'll see it get mounted right here. Now the media, if you're connecting media up to your machine, like a removable media device, it's going to be referenced here. And your service data will be under SRV. So one thing that's interesting to go on with here is every file in Linux, or everything in Linux is a file. Alright, so now that you've seen this and now that you understand that everything in Linux is a file, even a directory is a file in Linux, which actually makes things a lot easier. You'll see how that goes a little bit more as we go. So right here, we just listed off the different folders here. This is a very standardized version of Linux. We are going to go through some of the history of the Windows operating system, the OS 10 operating system, and we're going to go through the history of the Linux operating system and Unix as part of a further discussion. So that's one thing I wanted you to keep in mind, that none of this is standard, none of this is set in stone. In other words, you could put a configuration file under any one of these folders and it would likely work just fine as long as you have permission to it. This is best practice, and a lot of the stuff that's designed as system programming and system information, it will strictly follow these standards here. So let's look at an actual Linux configuration. So you do have your boot folder, we've discussed that. It's got your proc folder, we've discussed that. There's also a sys folder or directory, which is not on here, so a lot of system files also get run under the sys folder. There's mount, MNT, somewhere it is here, mount, so that's where I could mount other things up. I could mount media. I've got the SRV, there's the user folder, there's the home folder, there's bin, lib, OPT, there is the var folder, the etc folder. Root always has its own home, it seems like, in a lot of these systems. So root, this is the home for root. And then there's dev, which is not development, it's device files, like we've discussed. And we'll get into that, and we'll see that a little bit more later on as well. And then there is the temp folder, which we've also discussed. So this is a pretty good high-level layout here. This is where you'll actually be able to see the different folders in practice. So with that being said, I would like to proceed and go in and show you how things are laid out here. And I've showed you in Windows how the file systems are displayed and what have you. So right here, these are the actual different file systems that you might see on a Linux machine. And this is a very simple setup. As you can see, it's a small machine here. So this is how the files and file systems are actually laid out in Linux. And don't worry about this command, we will have this later on. Thank you. Alright, so this is what a computer similar to what we're going to do our Windows assignments on. This is a typical ordinary desktop PC. You'll probably use one just like it when you do your homework assignments. You're welcome to do your homework assignments on your own home PCs, laptops, whatever for your Windows assignments. If you're a Mac user, then Feel free to use any of the computer resources available to you here on campus, or use somebody else's computer. Your resources are kind of endless there. You might use your work computer if you have to. We're not going to do anything that's going to do any kind of damage or dig into the operating systems too deeply in this class, so that should be okay for you. But our Windows assignments will be done not on this computer, but on a computer very similar, just a typical desktop PC. Please make sure that your computer is running Windows 7 or newer. For the purpose of this class, I'll be demonstrating using Windows 10. The Albertus Magnus computers have all been upgraded to Windows 10 as well, so you'll be using a computer similar to this for your Windows assignments. For your Linux assignments, or Unix assignments, or even your Mac assignments, because remember, we'll learn very shortly that OS 10 is based on Linux and Unix, so actually Unix. So this is your Raspberry Pi, or this is my Raspberry Pi right here. As you can see, it's about the size of a credit card. I have my mouse sitting next to it right here, just so you can get an idea as to the size of it. This is an actual computer, and it's just this right here. That's the Raspberry Pi. This is a Raspberry Pi B+. Right here, this thing with the blue light on it, this is your wireless dongle. These are USB ports right here. This is your Ethernet network port. This right here is an HDMI port right here. This right here is basically just a micro SD card, and that provides your operating system. We're not going to be working with this too much right here, but this is the GPIO block. This is for sending commands to various devices. As you'll see on the next slide, this Raspberry Pi is mounted up to this homemade car project. I find these things fascinating because what other type of little device can you host a web page and have a remote control car at the same time running on? And I could probably run a database on it or something as well. So it's a very small, simplistic system, but it's very highly functional. This right here is a composite output, so for those old CRT monitors that you might want to put in through your stereo or something, you can plug those in here. This is going to be your audio output device right here. This light here shows that the power is on. So this is an HDMI port, so if you plug this into your television, this will have sound. Or if you wanted to do the composite method, you have your sound here, which is just like a speaker jack, and this is just an output jack for a composite video. So lots of ways to access the system and the networks. It can be wireless, you can wire in a network cable. So fascinating little devices. I have Raspbian Linux on here, which is derived from Debian Linux, and in fact I actually can't tell the difference. So that being said, we'll continue on here in a minute. I just wanted to show you a little bit of a different view here. So this actually has wheels on it, and this used to move at one time. It probably still does, but the motor controllers just eat these batteries up way too quickly, so I stopped playing with the project after that. But this is the Raspberry Pi that we'll be doing our class assignments on. Thank you.